Hi and Assalamualaikum. Today we from the members of Group 2, we would like to present about our mini project entitled Flood and Rain Control System. I'm happy that all the members here. This is our content. Table of content. All the content will be presented by different presenters. Chapter 1 is introduction by me, Norehana. Chapter 2 is planning by Abdul Hafiz. Chapter 3 is system design by Arista Ariana. Chapter 4 is result and discussion by Amirul Firdaus. Chapter 5 is conclusion by Abdul Hafiz. So I will start with introduction and brief introduction. This mini project is actually about monitoring and control in flood and rain situation by using sensor. And secondly, the system is built to warn residents when the water level reach each level when heavy rain hits the lead flood. And actually this system to help residents that live near full drainage system area such as a river. And lastly, we use more modern system to create the system in logic design. After we build the project, we have a few problem statement that we need to face. Firstly, sensor devices are connected with cost, size, and energy consumption reduction. And secondly, the buzzer we need to training to understand how to fix the problem without simply turning it off. And secondly, sensor is very sensitive to environment change. And why this project is necessary? Because when the flood comes with a warning, we can advise communities to take early precautions, and we want to prevent important documents and valuable items from being damaged. So, after we complete the mini project, we are able to demonstrate each set of the condition and achieve our objective. Firstly, we want to observe when the water reach each level using sensor. Secondly, to recreate circuit that is suitable to reduce flood damage. And lastly, to reduce property damage and valuable items. So that's all for me. We continue with Abdul Hafiz that explain about planning. Thank you.
Thank you, Rehana. Now I will be presenting about planning. This is our flowchart. First of all, we find project topic. So we do some research to find the project to do. Then we go to solution. We find a way to do the project. Then we go to the planning. We observe the solution and create step to do the project. Then we go to state diagram using more model state diagram. Then we create a state table to produce jacket flip-flop through table. Then we go to CAMAP to obtain simplified equation to reduce amount of bit of digital circuit. Then we go to logic circuit to simulate the simplified equation by using digital software. If it fail, we go back to the digital state and make it right. That's all from me. We proceed the presentation with Arina.
Thank you, Abdul Hafiz. Assalamualaikum and hi, my name is Arisa Ariana. I will continue with the system design. So this is the state diagram. This state diagram has 4 conditions, which is normal condition, warning 1 condition, warning 2 condition, and danger condition. So in normal condition, the output will be 0, 0, 0. And in warning 1 condition, the output will be 0, 0, 1, 1. In warning 2 condition, the output will be 0, 1, 1, 1. And in danger condition, the output will be 1, 1, 1. And then this state diagram will have a looping and feedback, as we can see here. The state 0 will change to state 1. State 1 will change to state 2, and state 2 will change to state 3. And for further explanation about the system and this project will be discussed in results and discussion. So I jump to the next slide, which is state table. So for the state table, we have a group for state 1, state 2, state 3, and state 4. So as we can see here, the present state is 0, 0, which means this is the group of the normal condition, and then 0, 1 for warning 1 condition, 1, 0 for warning 2 condition, and 1, 1 for danger condition. And this state table or truth table is created to have the input JK flip-flops. And then we go through for the Kano map. Kano map is designed for construct the simplified equation for the output. So we have LED1, LED2, LED3, and buzzer for the output. And this is the input flip-flops, which we're using the JK flip-flops. So we have JA, KA, JB, and KB for the Kano map. And then after we derive the Kano map, we design a circuit diagram using the simplified equation. So I will explain further for the input and output representation. So for the input, we're using the water level sensor. So we have three of sensors, which is all of the sensors will detect the level of water, each of the level. And for the output, we have 4 outputs, which 3 of it we using the LED, which is yellow LED, orange LED, and red LED. And the other one output is the buzzer. So all the LEDs is function to give an alert of the water level and its condition, which is the yellow LED will give an alert if it detect at a level 1, and for orange LED will detect at warning 2 area, and for the red LED will detect and give an alert at the dangerous area. For the buzzer will give an alert of the water level each of the level. So that's all from me. I will pass to the next presenter for the results and discussion. Thank you.
Thank you, Ariana. My name is Muhammad Amirul Firdaus bin Muhammad Faris. Today, I will present my part, which is about discussion and result. And it is a circuit diagram of our project. Without wasting time, we will go to the simulation that has been made. Okay. Before we begin, we must run the program first. We imagine when the water level rises to the sensor 1, sensor 1 will be activated. It is an early warning, and the output will respond. And the output will respond to LED1, buzzer, and will on. For the timing diagram, we have 3 output digits where sensor 1, LED1, and buzzer switch to digit 0 to 1. Okay, next, when the water level rises to sensor 2, sensor 2 will be activated, and it is a second warning, and the output will respond to LED 2, orange, and buzzer. So the timing diagram, we have 2 output digits, sensor 2 and LED 2 switch to digit 0 to 1. And the lastly is when the water level rises to sensor 3, sensor 3 will be activated, and it is the last warning or danger warning. The output will respond to LED 3, red, and buzzer also. And the timing diagram, we have 2 output digits where sensor 3 and LED 3 will switch to digit value 0 to 1. This project use a sequence where the output is not in one direction only, but it will revert back to the original. For example, when the water recedes, sensor 3 will be turned off, and the output LED will turn off too, and the digit for the value sensor 3 and LED 3 will turn 1 to 0. Okay, next, when the water recedes sensor 2. Sensor 2 will be turned off, and the output for LED 2 also will be turned off. So in this for the timing diagram, we have two outputs digits where sensor 2 and LED 2 switch to digit 1 to 0. Okay. Lastly, when the water recede, sensor 1 will be turned off, and for LED 1 will be turned off. So for the timing diagram, we have three output digits where sensor 1, LED 1 and buzzer switch to digit value 1 to 0. And now we want to share the error diagram process. The circuit diagram, we can see that sensor 2 and sensor 3 are switched on. However, the circuit shows no reaction. This is due to the fact that each operation must be followed one at a time. For example, sensor 1 buzzer, sensor 2 buzzer and sensor 3 buzzer. Consider the following scenario. Racing water should begin at level 1 to continue to level 2, and if the water does not stagnant and continues to travel to level 2, it does not exist. So this circuit identical to the last one. The only difference is that it is on off position, where the previous one was in the on position. We can observe that the output does not respond to the command off when the sensor 2 and when the sensor 2 or sensor 1 is off. Okay, it should be turned off. It should be turned off on sensor 3, then on sensor 2 and sensor 1, which following the established order. That's all from me. Thank you, and I will to the last part about conclusion.
Thank you, Amirul. Now presenting conclusion. To conclude our presentation, we have successfully achieved our objective and system that work as flood and rain control system. That's all from us. Thank you.
I'm an icon, man. And my girl about a 10. I should fuck her in the Benz.